All right, well, welcome back. Hopefully you guys enjoyed a little food. I know we did. I'm feeling a lot better now about life in general. That is still Adam Tuliper. I'm still Christopher Harrison, and this is still, yep, I'll let you read it on the screen. Now, when we left off with a hungry Christopher, we were kind of walking through a little bit of a demo on inheritance, and I couldn't find the right method that I was looking for, so I just want to close that off real quick and just go grab that, and then I'll let you do your thing.
Perfect.
You know, because I'm tired of talking. I'm sure everybody's tired of listening to me, but that's a different conversation. Sorry, this is who you're stuck with. But in any event, let me go back in and say public list and solo artist. So this is where we left off, that we had created that solo artist, which inherited from artist, and so now I just want to add on the get solo artists just to show off that we could go in and do that. So let's go in, and there we go, and then it's return, and then db set of type. There we go, and then we can go ahead and specify, in this case, solo artist, and this will just give us back the solo artist. And thank you for several people who mentioned in the chat window that that's what the correct answer was. And just to prove the point, let me go back to my artist controller, and I'm just going to real quick update index here. So rather than get all, I'm just going to go grab the solo artist, so that way we can just see that that's there. A little Control F5 action, chugga, and artists, and enter, and now we should notice that it's just simply the solo artist, and sure enough, there it is. So that's kind of the close of doing inheritance. And if you wanted to, you could of course go in and create a repository specific for solo artists and so forth. But hopefully that kind of helps paint the picture of how the basics of inheritance works inside of Entity Framework. So Adam.
Hi.
Hi. How are you feeling over there?
I'm feeling pretty good.
Good. I feel like I've done a lot of talking.
One of us?
Yeah, it makes one of us.
Two of us now.
Callback, yes. Yes. Well, I feel good because now you're going to talk. Now, up until now, we've sort of seen how to design classes by using convention, using attributes, but I know that there's more power to be had here.
There is. There's a lot more power to be had there. We're going to keep it kind of simple today, some basic cases on here. I've seen some questions in the chat room like, hey, can we do this kind of complex case here or there? You know, we want to build up. This is a jump start, so we're going to keep some simple cases. Any additional questions, post into the chat, reach us afterwards. I do want to point out in the break slide, somebody mentioned in the chat earlier my Twitter handle is not the correct one on there. It's at Adam Tuliper. So find me on Twitter there. And there's a couple things
that second L is silent.
The second, Tupler, there it is on the screen right there.
Yeah, that one's correct. That one's correct. On the break slides, it's wrong.
So a couple things that I've learned today. Resume generating event.
Yeah, RGE.
And I saw a couple of folks type in the chat room, chugga chugga.
Chugga chugga.
And I heard you do it.
Ah, yes.
Control F5.
Chugga chugga. Yeah.
That's where it comes from.
Yeah, so I'll move my mouse or do a little dance.
I like it. All right, so module 4, let's talk about managing your database.
And we've lost Danny in the back there.
The energy in this room, I love it. This is why I love doing these live events, right? It's a personal live energy. This is good, rather than sitting behind a boring microphone and talking. So I hope you guys like some of the personal aspect that we bring to this today.
Yeah.
All right, so managing the database. This is a very important thing. When you're writing your code, how do you keep your database and your code in sync? So we're going to talk about Fluent API. As Christopher said, this is another way of using code to configure the conventions for your database, primary keys, relationships, etc. And then we're going to look at code-first migrations, my #1 favorite feature of Entity Framework outside of making my life easier.
That's a bold statement.
Yeah,
yeah,
I know.
Favorite feature. Okay.
Favorite feature. It is.
All right.
The amount of time I've wasted over the years in trying to keep my database and code in sync, and managing my scripts, and using DB compare tools, and it's yeah, I love where it's at right now.
All right.
All right, so let's get started with Fluent API. Fluent. Now, a Fluent API, the name of it is not new to Entity Framework. A Fluent API is this nice API where you can kind of chain calls together. But first, let's take a step back. We were talking earlier about data annotations, attributes that existed in our entity classes. For example, you did the required attribute or string length attribute. And so why use those? They are simple and they work well for a lot of basic scenarios. Some like to see those attributes right on the class, right above the property that it affects. You open the class, you see required for title. Easy enough. I know it's required. And also, those attributes, there's a good handful of them that integrate directly with MVC validation. So you got a web page, you leave that field off, and you click Save. MVC recognizes that based on those annotations, data annotations, and gives you an error, basically saying, hey, this field's required, or their length is incorrect. So that's a great feature of it. It integrates automatically. It just works.
Yeah.
So let's take Fluent API. Why should you do that? Fluent API, one of the #1 reasons I hear people talk about it is they're software purists. They want their domain classes clean. If they have a customer or an album class, they want their properties in there. They want it as a plain old CLR object, a POCO, these basic classes, and they want all their configuration related to that class, all the metadata describing it, somewhere else. They don't want it all stuck in there, kind of mucking it up, even though we saw some simple cases. I've seen some really complicated classes with lots of properties, lots of attributes in them. Fluent API also has more supported operations than it does inside of data annotations. So you can do things like specifying, I've got a couple things listed there, advanced mappings, date time precision, non-Unicode strings. And you can also use view models for your views with the Fluent API. So I'll show you a really quick demo of that. That's kind of taking it up one notch, but we'll just look real briefly at that. And the idea behind a Fluent API is it uses this method cascading. So this last line kind of down here, let me try this guy. So we're referencing our album right here, dot property. We're using our name property, and then we're saying it is required, and then we're chaining on, it has max length of 60. So that takes the place of using the required attribute right here. And then this is the string length attribute right here. So it just chains all along. It's one line of code. Looks good.
Yeah.
All good to go.
I like it.
Like it.
Keeps the classes clean.
Now, the problem, when you start taking your data annotations and you separate them from your Fluent API, there's a couple things that you have to be aware of. So Entity Framework recognizes some of them. So in other words, if you use the required attribute on your entity, Entity Framework recognizes that. If you use string length, range, min length, max length, Entity Framework recognizes that. It doesn't recognize all of them, though. So there's kind of a disconnect between what Entity Framework supports and what MVC or some other technology might see in the data annotation namespace. They're kind of separate. And so it works, and so some purists have a problem. They're saying, well, you have the required attribute over here, and that is being used by MVC to figure out what fields are required. But yet, at the same time, it's being used by your database, your ORM, to kind of figure out what's required. So that one attribute is serving multiple purposes by different systems. So folks that like to have really clean code, the purists, so to say, they don't like that there's dual things using the same item. So they like to break these things out a little bit. So that kind of brings up the question, how would we use this Fluent API without data annotations? And this is kind of almost a chicken before the egg, and it's almost. I just want to show you a quick little code sample here. This is a question that comes up a lot, and I'm sure somebody's going to ask it in the chat today. So if we want to use the Fluent API without data annotation, so let's say we're going to take a view model. That's a very common thing that we're using in MVC. Right now, all of our demos to date, we've been using like an album as our entity. And it's serving dual purpose, which works in a lot of great basic applications. We have an album entity, but we're also taking that entity and displaying it out. We're passing it down the MVC to display on a web page. Also serving dual purposes. It's our data entity. It's also acting kind of as our view model. In other words, what we're going to display to the page. So if we want to kind of split that out a little bit, how would we validate if we're not using, if we're not going to be using these data annotations on our MVC, our Entity Framework entities? And so let me just copy out a little code here to show you in a web app. Let's go back to web application number 5. Not to be confused with
web application 4 or 3.
Or love potion number 9. Ah, the randomness today.
We apologize for planting that earworm.
OK, so let's assume here, let's come down to just an empty area. Let's make an empty area. And I'm going to extract this guy out. I'm going to create a view model here. And before I talk about this, let's go over here, and we're going to create a view model, which we can see in this application. We've already got a couple of view models here. We'll call this album edit view model, meant only for when we are editing an album.
OK.
And this class, let's go ahead and fix up a couple of these references here. There's our data annotations.
All that you're doing is you're just simply throwing in the a class that you'd already created, and we've got the attributes that we've already seen. So nothing really fancy here.
Nothing fancy. This, in this particular case, looks an awful lot like our actual entity.
Yeah.
And sometimes they do. Sometimes folks say, well, they look almost the exact same. Yes, sometimes it creates more code. This is a simple case, so the two of them are going to look very similar here. Let's take this example. This is the data we're going to display on our web page. Let's say somebody's going to edit an album, and we want to show these properties. Let's take Entity Framework out of the picture for a second here. This is the data we're going to display on our web page. Regardless of where we get it, whether we enter it manually or we get it from a database, however we get it, this is what we're displaying on our web page.
Yep. That's
a view model. It just simply states, this is what we want on our page. In fact, there's even a simpler version if we only want to show a title and an album art URL. So let's go back to my controller here, and I'll walk you through the code that I pasted here in 1 second. My album class on this one is a little simpler, so let's fix up, let's make this easy. My album class is missing a, we can tell by the red squigglies here, we need artist ID and genre ID.
One of the little things that Adam could do in there is you can actually just tell Visual Studio to go in and generate the properties for you as well, just as a little side note while...
well, that's true, because we do know the type on these. That is a good point.
Yeah.
Let's actually do that here. Go to generate my property.
Yep.
And go to generate my property, and generate my property.
That's really helpful. That a lot of times, you don't want to go back to the class and update that right on the fly. So
there we go.
Yep.
As long as we know the particular type,
timestamp attribute.
As long as we know the type, we can do this, generate it perfectly.
Yep.
Okay, so now we've got this particular album entity. So this is what's going to be used in the database. Notice we don't have any kind of data annotations here. If we go to our view model, we have a string length, a string length. We could actually come in here and say this is required. So this has no validation on it yet. This has no rule specified. And we're going to get to that shortly when we talk about some basics of what the Fluent API looks like. This is kind of the whole quasi-chicken before the egg deal here. We've got our view model, which uses the data annotations you were talking about earlier. We've got string length and required. So on the web page itself, this is the required fields. So let's go back to our controller here. And let's look at the flow of what happens now. So we're no longer sending an entity to our web page here. We're actually using an album edit view model.
Right.
And when we post back, we'll be getting an album edit view model. There was a question earlier in the chat room on how we would be able to validate that if we're doing anything kind of custom here. Or when you had your repository method, somebody said, how does that validation work then with MVC? If you're doing a repository, where does the validation happen? Well, in MVC, the validation is happening right here. When you post back, it says, is your model state valid? Well, what is that being determined from? Album edit view model. And if we look at our album edit view model, that is what it's going to be used for our model state validation right there. And so there's two things we need to do right here. We need to take this view model, which is not an entity framework entity. It is just a plain old class that's coming back from our web page. It's getting mapped to these values. And we need to map those fields over to a new entity. So we can create that new entity. And we can add it, as Christopher showed earlier, we can add this to our context. When you add any new entity and you say its state is modified, and you do it like this, it attaches it to the context. It says, all right, this is pending creation in the database. Of course, we need to save our changes. Now, here's the one little thing we have to look for. This is where kind of the mismatch can happen. We might have validation rules that may exist in our database. We might have different validation rules that exist in our view model. We might have fields that don't show up in our view model that might be in our database and vice versa. So a common technique for handling that is right here, we're catching a DB entity validation exception. If that happens, we're going to step through each property in this validation and simply map it to our errors. In other words, if we're missing, let's say, for example, we leave out title. Title is going to be an entity validation error, and we're just going to add that to our local model state. The code for this, and one of the other things I'm going to show for the next module for concurrency, I'm going to, at the end of the day today, make sure this is all over on the GitHub site, which we'll post the URL back into the chat room. We've posted a couple times before. We'll make sure that's out there a few more times today as well.
OK, perfect.
So this is a common technique for using a view model and mapping over to Entity Framework, and kind of vice versa. You're coming into the web page, checking if your view model is valid. If your view model is valid, you are then copying those properties over to an entity. You are saving your entity.
We'll get to that later.
Saving your entity. If you happen to have any validations, you're going to map them to errors to show onto your web page. Let the user fix them. And then return back, and voila, you're all done. So now let's kind of go the other route and start diving more into kind of the Fluent API details. We just kind of assumed that we had some other Fluent API defining what our database was going to look like, what was required, string length, but we didn't see it because we're not using data annotations on our entity. So what does the Fluent API support? Many things. One of the common things, and we'll look at a case of this today, is mapping between, take this guy here, customer.uniqueID_ID, and we want to map that to a customer.customer ID. So I've worked at places that have had some really, really horrendous field names. So if you want to change those and make your code look nicer and map it to better values in the code, it allows that kind of mapping to be done. You can go single type, so to multiple tables. So for example, you could have an album, and you could split that out to multiple tables in your database, and vice versa. You could have multiple entities that combine to a single table in your database. Schema mapping, I'll show you how you can specify your schema here. Mapping table per type, table per class, and then table splitting, kind of what I was touching upon, where you can have 2-to-1, 1-to-2, 1-to-many table versus type. You can specify keys, length, index, many different things. So we're going to look at a couple of basic examples here. You can do composite keys. Actually, we'll do a demo of that as well. And the main way that you work with this is you override on-model creating in your DB context. So I'll show you how we generate this code really easy. Visual Studio will generate that for you. We can generate a default schema. Let's go ahead and look at an actual demo of doing this.
So this doesn't have to go inside of a different class. It can just be right inside that same DB context.
It can be right inside the context. It actually can be inside of another configuration class as well.
Okay.
When I've reversed engineered some really complex databases with a lot of rules in there, and the reverse engineer tool at the time created me all my separate classes. Let's say I had a customer table. It created my customer logic over here. It had my order logic over here, my whatever logic over here. So it split it apart all into separate classes. For what we're doing here today, it's a smaller database. We're going to keep it all inside our one on-model creating class.
OK, perfect.
OK, so let's go back and go back to a console application, shall we? We shall.
We shall.
Let's create a new one. Let's do this from scratch. Let's copy out some of this guy, just so we can clean it up a little bit. The great thing with Entity Framework and doing this is you can do this really fast. For those in the audience, do you remember the command? Install-package entity frame. And if you're lazy like me when it comes to typing with something with autocomplete, framework. You ever do that with autocomplete? Like you're 2 characters from the end,
yes,
and you just hit tab. Like really, I just typed 12 characters. All right, let's add on our album class on here that we've been using. And I'll remove this guy right here. And we want a DB context class. So let's use save all that. Let me just grab my context out of here. It's a little bit, we'll trim this guy down. I don't know why I thought of it now, but I just thought of something now. One of the questions that some folks asked inside of the chat room earlier was why the SQL Management Studio kept opening and reclosing it, opening and closing. And correct me if I'm wrong, but I think that was because to release the hold on your database.
Yeah, you know, it's one of those where that was the simplest thing that I could do, was just simply close it, reopen it, which is, you know, relatively easy for me to do. The other thing I could have done is just made sure that there wasn't anything touching that database, but I kept drilling into it, and then it was just easier, you know, let me just close it out rather than having to go in and clean things up.
Just easier to do.
Yeah, and that was it. That was the only reason I was doing that.
All right, so here we've got our context. Let's fix up this assembly reference.
Okay, so all that Adam has done here is he's just gone back in, created a brand new album, and then I noticed he used GUID, which a lot of people are asking about.
We'll actually get to that shortly.
Okay, all right, carry on.
I will do that.
Carry on, I won't get in your way. I'll just sit over here, drink my water.
Okay, so inside of our context class, public override. And Visual Studio is pretty smart here. Gives you a whole bunch of stuff. We want on model creating. This is the method that we're going to go in here and kind of configure everything. So if we want to set our primary keys, if we want to do a whole bunch of stuff, in fact, we will check out, I think we'll do about 6 of these demos today.
6.
Maybe 4. All right, so schema in a database. Let's comment this guy out for now, and let's look at this one. All right, so first and foremost here, early versions of the reverse engineer tool actually fixed everything to DBO. You had to go and fix up your own schemas. With what we have here, if we want to change any kind of default schema, I've noticed some folks have talked about having a very large database with 600-700 tables, and I've seen some big, ugly, brute databases in my time, and a lot of them have different schemas inside of them. So if you're thinking about using Entity Framework to have like 700 entities for that one database, that might work. There's been a lot of questions about performance. That's a lot of entities to kind of spit up. It's a one-time hit when you start your application up. But I kind of have to ask the question, is that always necessary? A lot of times you're running a new application to go on a legacy database. You don't have to map out every single entity in your database. You're going to map out what entities this particular single application is going to use. Back in the day when I started application development many years ago, everybody liked to have these big, humongous objects that mapped everything, and they could share these between apps. And it actually kind of broke down pretty fast because other apps needed specialized cases. And to me, I think of it the same way. If I'm developing a new app and I've got a database with 200 tables, and I'm only accessing 12 tables, I'm only going to have 12 entities in my application. I don't actually care about the rest of them. I don't want to maintain them in my app. I don't want to have to worry about them.
Yep.
So one of the things you can do too is create new tables, specify a particular schema, and override that schema here, the Fluent API. Secondly, my album. I have a key here specified of album ID. So Entity Framework does have some built-in rules as to what it's doing with your primary key detection. You can override these here and specify what the key is. Christopher was talking earlier about using the key attribute. So this is the similar thing of doing this right here. Folks have asked, what about doing things with a composite key? So let's take our album. What would be a good composite key for something like album? Can I even think of a use case for that?
Maybe, yeah, the release year and the title?
You know what, we'll assume for the, just for the argument's sake here that these are going to be our 2 keys, right? So
sure.
This will map to really any scenario. You just think of something that has two keys, right? Sometimes it's just easier to kind of work with what we have. And so in this particular case, if we have a single key here, we can specify that. If we have a composite key here, we can do something literally this simple. Create this anonymous object, t.albumid, comma, t.whatever other thing you want to be your key.
Oh, all right. That's easy.
There. That's your composite key. What was it yelling at me at here? Let's see what it was yelling at.
I think you need a new in front of that.
This should be OK here. Let's see what the error is here. Semicolon expected. What did I hose? All right, I'll come back to this in 1 second.
I think you need a new in front of it. Just give it a shot. Humor me for 2 seconds after the, yeah, just say new.
I should be able to do that as an anonymous object, though. You know what? I'm going to.
Well, yeah, and that's what you need is you need that new there.
Yes, you're right. I do. Create the new anonymous object.
Yep.
You know what? I was feeling good after lunch. Now you know what's happening now? The lunch is setting in.
See, yep.
You're getting so hungry, you raise the
Post-lunch lull.
Yeah.
Yeah.
Give me about 10 minutes, get fired up. So, yes, absolutely right, Christopher. So, new up that anonymous object here. Yes, yes. The other problem is I've been working too much with JavaScript lately. So that kind of has altered my thinking.
Right, yeah. You're writing JSON now.
Yes. All right, so that's another way. So composite key right there. Let's go back. Let's not make the album ID and title our composite key. Let's go back to a basic scenario here. Now, another thing that you'll commonly see in legacy databases especially is this guy here, the title, might be in the database as varchar 100, for example. So varchar is not nvarchar, so it's not internationalized here. And so what we can do in that case, this is something that the Fluent API allows you to do that data annotations does not. And so we can come in here on our property, so we can chain this off on any particular property here in our model. So we can say title, price, etc. In this case, we're going to do title dot is Unicode false. So this will tell the Fluent API and in turn Entity Framework that this is going to map to a varchar or varchar, if you may, column inside of your database.
So rather than nvarchar.
Rather than, what's that?
Rather than nvarchar.
Rather than nvarchar, that is exactly true.
Cool.
So let's go one other case here, because you noticed earlier, I initially had GUID there. But before we go to GUID, let's take the case of...
A lot of people have been asking about GUID.
All right, so right now, our album ID is just an integer. By default, it's going to be an identity field, auto number. So 1, 2, 3, 4, 5, et cetera, on and on and on. I've seen many databases where you need some numeric ID, but you don't want it to be an identity field. And so in that case, we can do something as simple like this. Bring in that namespace. All right, so we have our album that we're configuring. You'll see this kind of common thing here, model builder dot entity of type of your entity there. First step. Now we're saying we need to reference a property on here, our album ID. Has database generated option, dot none. Now, you can do the same thing with data annotations, but again, this is something that I really prefer to actually have in this class to kind of just keep it a little bit cleaner outside of there. When I look at my model or my album class, for example, I don't want to come in here and see personal preference that I'm overriding my keys here, I'm doing this. This is all my configuration for me. It keeps it a little bit cleaner for me, personal preference. So the way that this stands right now, this will not do an identity in your database. This is a numeric, but you are going to have to supply the number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Let's build one step further from this. Let's take the case of this right here. Let's change our album ID to GUID, okay? Let's comment this out. We'll just keep it up there so you can see it. The difference is here. So we're going to configure our property. Same thing, has database generated option. It is an identity field. And then we've got this specified now. If you notice, I've changed it from an int to a GUID. Let's compile, make sure we're good so far. And let's go ahead and write some code here. Just really fast, we'll do using context equals new. So we're going to new up our context, and we will say context, we'll say, now we could do this inline. I just want to separate this out just a little bit here. We're not going to specify our album ID. Our price is going to be $9.95. And our title is going to be Wish. I didn't forget that. Context dot albums dot add, because we're adding a new one. Oops. Get that caps lock key off there. Sometimes I wish they would ban the caps lock key. Good on a phone, bad on a keyboard. Okay, save our changes. Context. See, I hit I hit the caps lock again. Context.save changes. There we go. All right, so let's run this and see what happens here. All right, so my program ran, exited. Let's go look at this database. And so this was, this program is console application 6. So let's go ahead and run SQL Management Studio. I could do this in here in Visual Studio as well. Let's connect to that database. Here we have our console application 6. Oops, not the diagram, our tables. There we go. And we can see our album ID. It's a unique identifier, not null. And we'll see what happens very, very shortly when we generate some code around this.
All right.
But this is it right now. So we've got a GUID, which on the database side is called a unique identifier. You can see that here. And you might be wondering about how we're going to be generating that GUID. So we're telling it right here, this is a unique identifier, but what about handling the lifetime of that GUID? Do we have to generate a new one each time? And we'll see when we talk about migrations in just a little bit how that actually gets handled. All right, let me see if there's another little case here I want to show you. Let's talk about, somebody mentioned one-to-one. Let's look at something with one-to-one real quick. Kind of to map over to what you were talking about.
I always like that compare and contrast, kind of see it, how it works both ways. Type, type, type.
Type, 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 tab, tab, type, 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 tab, tab. Come back down to our configuration class here. And let's kill what we got here.
Somebody asked while you're typing away, and I just answered in here, kind of a really neat question, which is if you have a private property, how do you store that inside the database? And the answer is that what you wind up having to do is you have to create a configuration class specifically for that object and put it inside the object, because only if you're inside the object can you access that private property. And then when you go into the on-model creating, make sure that you create an instance of that configuration. So it's a little bit tricky, but the short answer is it can be done.
Cool, very cool. All right, so what I've done here, very simple. There's two classes. So you were talking earlier, I think you had artist and artist detail, right?
As my one-to-one, yes.
As your one-to-one. So we're talking here, I'm using album, so I'll just use album and album detail.
Sure.
That's something you commonly see on the sites, right? Yep. So in our album class, we've got our relationship to our album detail here. And in our album detail class, we can see that we're referencing an album ID and the album. Now we're not actually going to have an album detail ID as a primary key here. We're going to have the album ID. This is going to be one-to-one. Technically, in this case, it could be 1 to 0 or 1 to 1. That's the way we're going to configure this. And so we need to tell Entity Framework that our album detail has the key. And this is exactly the same thing you demonstrated with data annotations earlier. You did a key.
And then I also did foreign key.
So here, what we're going to do is specify has a key.
Yep.
And we're going to specify next, using a Fluent API, that our album has an optional album detail.
Okay.
But in turn, our album detail has to have a required album.
Okay.
So it's kind of going here, down, and back again in a sense. But you kind of read it out. Our album has optional album detail. You might almost read with required as being part of this. But here we're talking about album detail, and we're going back the other way. Album detail has a required album.
I like it.
And that does it for you. Because we're saying has optional, this is 1 to 0 relationship here. We could say has required, and we could change this up a little bit here. Has required and with required principal. That's a required 1-to-1 relationship. I like the 1 to 0 because in this particular case, an album detail could exist without our album. That's what I've specified here. Alrighty, let's move on a little bit. So the Fluent API basics. On model creating, you override that and you specify everything you want there. Again, you can have it all kind of bunched into that method, or you can have other classes that you can configure that through. So remapping legacy tables. As I mentioned, I've been in a lot of environments that I've looked at foreign keys, and they were named like primary underscore key and foreign underscore key throughout the entire database with hundreds of tables everywhere. Makes it awful if you're trying to search through schemas and try to find things in the database. So I like code that I can read and.
Yeah, tell you what, let's make a deal. If you get to remove the caps lock key, I get to remove the underscore. Is that
Yes.
is that a fair
Yes.
trade? Okay, perfect.
Yes.
All right, done and done.
So Fluent API gives you some different mapping scenarios where you can basically say any column name in your database can map to any property inside of your class. Vice versa, you can change these mapping names around. So you can clean up your code and you can have it however you want in your database. You don't have to fight with your DBA. You can just change this up. So Fluent API, as I mentioned earlier, allows you to do things like entity splitting. So what I talked about here, multiple entities per table and multiple tables per entity, and also table per class, which is basically what we've been looking at so far.
Yeah, everything has been table per class up till now.
Christopher looked at a bit of this, table per type. No, actually, you didn't. You had kind of the inverse of this. You had one table that had all of these subclasses being rolled up in that one table.
Yep.
All right. Oops. Let's go back. Well, it's going to be the demo of the next slide anyway here. Fluent API remapping, tables, and columns.
But now we got to see that demo slide in full screen. So
Right.
yeah, that was good.
Oh. Well, now as you're scrolling through the video later on, you can know where to stop. Oh.
Yes, exactly.
All right. This is going to be extremely simple. The idea behind this is super basic. So inside of our onModel creating, I'm going to move this down because we're going to get back to a little bit of this shortly here. So if I want to take my album table up here, and in my database, that happens to be called album info. What we can do is, again, use our configuration here. So if we type this out, modelbuilder.entity album dot, let's see what kind of properties we have here. This is where we can specify as required, relationship has many, has optional, our mappings, to table. And when we look at that constructor, we can take a table name or a schema name. Those are our only two options. So in this case, I'm going to specify that album is going to map to album info, and my schema is DBO. Secondly, let's take our property. Let's fix this up a little bit so we can read it on the screen. So our title, talking about underscores in database, maybe inside of our database we have this guy right here. See that, Christopher? You see that all the time, too.
Yeah.
So if you are working with a legacy database that has that, it's fine. If that's your naming convention, that's fine. If you're currently using underscores, consider not using underscores. It looks,
Just don't. Just stop. Don't, please.
So
No.
use
Okay,
consistency. Right. We've been scarred. We've seen a lot of bad databases in our lives. That's why we're kind of so adamant about this. We like consistency. I kind of like the naming to match code naming. I like primary keys, key names to be spelled out. Customer ID. That way I can search through it in my database schema.
Makes so much sense.
Yeah.
Yeah.
So let's take our property. Title is going to map to has column name. Up here, it's called toTable, not has table name. It's called toTable, but down here it's has column name. I'm going to change this one tiny little bit here because what we have right now in our database has already been created, and our database has actually already been created with the album table. So if I run this right now, we could potentially run into an issue. So let's do this, shall we? We shall. Let's take.
We shall.
We'll build upon something that Christopher talked about here. And we'll take our music context, and we'll say that our we're going to do our database dot set initializer, and we will call that music context. New drop create database always, and that takes our music context as well. Okay, drop and recreate the database every single time. And let's see what happens here in our database. Let's hope nothing blows up here, because we're definitely running a little bit short on time. The demo gods are going to yell at me soon. All right, let's go ahead and look back in Management Studio here. Notice our table now. What's it called?
Album info.
Album info. Perfect. Easy enough. We set that, it generates it for us, it maps album to album info. Really easy scenario to use. Okay, next, my favorite feature about Entity Framework.
Your favorite. You're very excited about
My
this.
very favorite.
Startled
This
me.
is like really
like trying
cool.
to nap over here. You woke me up.
Well, I figured, after lunch, we got to get the energy going.
Absolutely.
Okay, so in traditional database management, let's talk about the old style way of doing things first. We can manage our scripts in a bunch of various ways. We can write our code and then write our SQL, and then we can create our database from that SQL. We can create our database and in turn write our code to try to match a database, script a database and push it through our dev, QA, production environments, and hope it matches and hope our code matches. There's all sorts of challenges with that. So let me show you kind of one basic way of doing this. I don't want to call it the legacy way, because some folks, this will work just fine for them. This is not code first migrations, what I'm going to show you first. Let me connect to local DB, MS SQL local DB, and let's find, oops, it's called MS SQL local DB, not MS SQL.
I liked that you said it and didn't type it.
Sound like that until the tab completion, when you're 2 characters away.
Yeah.
I left the 2 characters off. Okay, so we did console application 6. So we're going to use our existing database here. And what we're going to do,
Visual Studio will just listen to you and type it in for you.
there's the same thing that we were just looking at over here with our SQL Management Studio. So let me close Management Studio out and show you in Visual Studio we connected to this. Now, here's an important point. Browse in SQL Server Object Explorer. We browse that, and it opens a database here in a very similar looking window. And what we can do then is right-click on this, and we can create a new project. And this says, OK, we'll accept some defaults here. Import of database schema has started. So again, this is not code first. This is kind of a traditional way of managing this. We have a database that exists. We want to somehow create scripts for that. You might have a DBA. I've been in a lot of environments where the developer is a DBA, and I'm sure there's a lot of people in the audience that are kind of just like that. Or the DBA has got other things to do. He's like, well, do you have scripts for me to run in production? I'll run them for you, but we have to go through change control here. So this has generated a database project for us. And in here, we can see, we open this up, and here's all the SQL. We can source control these scripts. We can give them over to our DBA, or we can run them ourselves. The problem with this is what happens if I go and add new properties to my database. Let me say I add new properties to my code, then I have to add them to my database, then I have to redo this process over and over and over again ad nauseum.
Sound a whole lot of fun.
Keeping code and database in sync is not fun. There's an issue with it. It's significant manual effort to be able to do this.
In sync is not fun.
In sync is not fun.
See what I did there?
I did. And typically also, you apply those scripts to production. How do you roll them back? You had to write undo scripts, which means you had to test them, which took a lot of time. So typically, most people didn't write undo scripts.
Yep.
Ensuring that your app matched your database version was challenging. I've been in production environments plenty of times where something was deployed to production. Oh, look, somebody forgot one database field inside of the scripts. All sorts of problems like that. Validation issues. We had string customer in our code. It was supposed to validate to varchar 50. All sorts of production bugs. This process is a pain to manage. So what would help here? Our apps, we want to write our code, and it would be nice to have our database kind of managed for us. And that is kind of where code first applies. We write the code, and code first migration handles, I actually said here, this is where code first applies. This should be code first database migrations. So what are the migrations here? Migrations are pretty cool. This gives you a way to manage your development cycle. So this gives you the scripts. You write your code. It will generate the scripts for you. You create snapshots in time that are called migrations. You can, in turn, generate these migrations, generate scripts at any point in time. You can upgrade, downgrade, and I'll show you a couple techniques for doing that. Now, what about for existing databases? We can use this on existing databases as well. This command right here, add-migration initial -ignore changes. And we'll try to look at a quick demo of that as well. So how do they work? Code by default is created under the migrations folder.
Okay.
Each new migration that we add adds code to this folder. It's code that only Entity Framework looks at. And we can upgrade, downgrade, we can overwrite existing migrations. So for example, let's say we add some ship info to one of our classes, customer ship info, for example. And then we create this migration. We have this snapshot in time, but then we're like, oh, we forgot to add state. So we add our state. Do we have to add another migration, another? No. We can overwrite that last snapshot and encompass all of our new changes to it. And I'll show you what this is going to look like from the Visual Studio side. When we're all done, we simply push those updates to the database. Christopher was running update-database earlier. My favorite one is update-database-script, so I can see what my code looks like that I'm going to apply to my database. Now, you had the automatic migrations configured, and you did put a warning around there. This is not something that you would keep enabled for production. Some folks like it in their development environment because they don't have to constantly add migrations. It's good for quick testing, right?
Right, yep.
OK, so let's look at setting up migrations. Let's close this guy out, close this guy out. And we're going to keep everything kind of how we have it right now. This looks good. Let's delete this, just clean this up a little bit. So we've got in our program right now, we have our album class and album detail. So imagine that we want to script this out. Let's go ahead and see, we have an existing database here.
Oh, no.
Goodbye. All right, that database is now gone. So we can kind of start from scratch here.
What a world.
I'm going to delete that database project I generated because we won't use it.
And we also got rid of the database.
And we got rid of the database. Boom, gone. OK. What we want to do now is we've got this code. How do we generate our database from there? So Entity Framework, if we run this, it will create it automatically for us. Maybe I don't want it to create automatically for us. I want to enable migrations. So our package manager console, enable migrations. Notice it's created a migrations folder here for me. And inside of there, there's this configuration class.
And there's automatic migrations.
Yep. Now, we don't have anything else here right now. So let's go ahead and add a migration. I like to call my first one initial. And this is going to this is going to contain my album and album details in it. And look over here. It creates this class. It's got a name and a timestamp on there. One of the ways on how it knows which order to run them in. And if I look at this, it says, OK, when you're going up, in other words, when you're moving up to this migration, we're going to create a table. This is Entity Framework's code. You don't call this. It does this. You can hook into this process, but typically you don't have to worry about this. Create table. You're going to look at the album details here. That's a table going to be created with an album ID, description. All of our fields here, we can see the relationships. And if we want to move down, so if we want to roll back from this migration, here's the commands that Entity Framework understands how we roll this back. That's all well and good. It's created this stuff for me. How do I use it? Update-database-script. And if we look at this, this is everything that it needs to apply to the database to make the database match my code right now. So it creates album details. And actually, all right, cool. I just want to check something here. So we have our album details being created. We have our album info being created here. We have a constraint being created, and then we see this migrations history table. That is where the magic for your database migrations comes into play here. So behind the scenes, this table is used by database migrations to essentially hold these snapshots in them, and it will actually serialize out what your model looks like. That's what this long, if we look over here, see this long binary data? This is essentially your class is serialized, so it knows what your database, what your code looks like versus what's in the database. And so this is how you can kind of keep these values in sync. So I can take these scripts, I can apply them to my dev environment. I wouldn't be doing the migrations in production. This is for my dev environment. So I can just update this database automatically right now. There we go. If I say update my database again, let's see, is there anything pending in my database? Nope. There's no script that's been created. Let's add another migration. Let's come into my class here. And on my album class, public, let's do string. What should we do here? Actually, I know what we can do. We can do, we'll do date time, release date.
Perfect. Love it.
Cool. He's good. He's good.
Is that all right?
It's all right. It's all right. I'm going to add, I've added some code here. So I need to add another migration. Add migration. And I can call it, it's freeform text. Let me increase the size of this a little bit here. I can call it anything I want. Added release date. And notice it's created another class here, added release date. In order to move up to this migration, we need to add my release date field. Its date time nullable is false. If I wanted it nullable, I would put a question mark after it. If I want to go down, I just simply drop that column. So let's go ahead and update database script. So I should see only one field being applied here. Separate this out. There it is. There's my release date being added. And then it's going to upgrade my migrations history table with the current snapshot of what my code looks like. If I need to, I'm doing development, I realize that what I just did was not right. I don't like what I just did. I need to roll back a particular version.
I don't like what you just did.
I don't like what I just did either. So update database script. I can target a particular migration here. So I want to go back to my initial migration. So I can say target migration is initial. So that will look at the state of what I have now, and it figures out how to go back to it by looking at these migrations, saying, OK, I've got this one here. In order to remove it, I've got to get rid of this column. If I had 10 more, we'd do the same thing. We'd look at the down method, figure out which one to do in order, and create that for me. So let's see what this looks like. Update database script target migration initial. Update, oh, yes, aha. It says there are no changes. Well, of course, because I didn't actually apply my, my changes to my database yet. Remember, I have this pending column I need to add to my database. I didn't update my database yet from it. So let's go ahead and do that. Update database. Now, I want to roll back to my initial migration. I've just added that one column. I want to go back to my initial state here, my initial migration. And this is the code here to go ahead and drop it and delete that migration history from the database. So we're going back a version in the database. Perfect. Let's go ahead and do that. I'll remove my script so it actually does it. Cool. Let's say I realize that migration was garbage and I don't like it. I can just delete that migration. And I can actually go back to my code here and just remove that column from here, and the world is good. Now let's say I've really hosed my database. I've added a whole bunch of garbage here and a bunch of different migrations. And you know what? I need to just kind of start over here. What we can do here is we can say update database. Let's script it. My target migration is, and this is something you can use tab completion for if you forget. Target migration is, I'll type $INI, initial database. That special $initial database is what the state of your database was before you started adding migrations to it, which I had an empty database at that point in time. Mm-hmm. So if I look at everything here, it says, hey, we're going to kill album info, album details, and migration history. Make sense?
Makes sense.
This is how we roll back. This is how we move between these versions.
I love it.
So let's take one more scenario here. Let's go. Two more scenarios, we'll say. Customizing migrations.
Two more scenarios.
Two more scenarios.
But only two.
Only two. We are getting short on time. Customizing migrations, we'll keep this one really short. What happens if we need to have a little bit of control over this process? Maybe there's a bunch of fields already inside of the database. So we'll take one example here. Let's go back to our initial migration here. Notice, when it's applying this to the database and generating our scripts for us, let's find our price. Let's say we added price here. Let's do this, shall we?
We shall.
I'm going to remove the price from my album. And let's go ahead and add migrations. All I did, I just deleted that folder, my migrations folder. So enable migrations. Oops, let's build this first. Okay, enable my migrations. And again, it's because I deleted my migrations folder. We're starting from scratch again here, because I want to show you how you can customize some of this data a little bit. We've enabled migrations. Let's add our initial migration. So that's going to write album and album info SQL out here. And you notice, by kind of mucking around here, we've run into an interesting problem. It's already looked at my database, which exists, and says, oh yeah, I see you have information in the database. We kind of have a mismatch of information here. So in this case, I thought I reset my state back, but I actually didn't. There's already a database sitting out there. I can connect to it again here. This one right here, I will refresh that database. And notice, even though I deleted my migrations folder, my database is still there.
Mm-hmm.
So I can reset the state of my database, update it, delete my migrations history table.
And this is a big thing that that Adam's walking through, and I'm waiting for the update database there, is, you know, because a lot of times you will sort of get yourself stuck that that you made a mistake somewhere along the way. You just want to delete your migrations, and away you go from there. Then all you have to do is just delete the migration history table, delete the migrations folder, and then, as you're going to see here, you can then just tell it to go again, and it will go ahead and handle your updates.
And there we go. And so we have our create table being added here. Now I want to go ahead and I want to add price, because I want to customize this a little bit. Let's go ahead and update my database. So it's going to create my tables here. And it gave me a problem. Didn't delete that table I told it to, it looks like. Let's go ahead and do this one more time. OK, now if I refresh this, all right, there's my database. Let's go ahead and add price here. So I added my price, this guy right here to my album. I'm going to add a migration saying I've added price. What we're going to do is customize some of these potential values. Maybe I have 100 rows in my database or 10,000 rows. How do I specify defaults for those, for all the existing ones that are out there? So add migration, added price. Now if I look at this migration here for added price, we are adding this column. It's a decimal, it's nullable, not nullable, I should say, precision and scale. Well, what about all those rows in my database? How do I change this so that we can give them default values? And on the very end of this constructor here, we can specify a default value. So over here, default value, that's it. We're saying for every row in the database, when you add this price column, for every one, we're going to specify the default values being $9.95. And so that's how you can hook into this process and customize some of this data. You can do a lot more with that there. I just wanted to show you a really, really, really simple version of that. All right, last, let's talk about managing an existing database. That is an extremely, extremely, extremely simple command. That was the one I had a couple slides back where you basically force, just to show you on the slide here, that was this guy right here. Add migration, initial, ignore changes. So let's assume that we have an existing database. We've reversed engineered it into our existing database. So I've showed you some of that code earlier. Our database here matches. Let me make sure I have my price. We'll add that price back on here in 1 second. So work with me here. We have an existing database. I showed you earlier how to reverse engineer it.
Pretend that we do.
Pretend we reverse engineered it into this project. well, how do we work with this data? Like, it's already in a database. How do I add my migrations? How do I do this here? So first things first, enable migrations. Add migration, initial, ignore changes. That is the important command right there.
The ignore changes.
Ignore changes. This guy right there.
Initial could have just been Wibble, because you're just giving it the name.
Chugga, chugga, chugga.
Chugga, chugga, chugga.
Anything you want to name it. If I look at this migration, remember the other one for my up and down had all this code in there? This says, yeah, we don't need to do anything for up, anything to down. This is the state of your initial database. Let's customize that. Let's go ahead and add that price back in. There we go. We added the price to our album, which is not in our database yet. And we will add migration.
Migration.
Added price. And we're going to apply our existing, yeah. All that happened right now, that basically said, hey, you've defined a migration that has nothing in it. You still need to write that row out in the migrations history table. The database still needs to know that you're working with an empty state here. So added price, we're going to add this guy. And then now we're going to update database script. There we go. This is how we're going to move to this migration. Let's go ahead and update our database. Perfect. If I refresh my database here, price has been added. If I need to roll back to my initial database, I reverse engineered the database. I need to roll back. Remember what we did here? Update database. I'll script it. My target migration was my initial database. The last demo, I started with an empty database, so it was empty. With this one, I reverse engineered the existing database. So I had a bunch of stuff in there already. Let's see what happens when I say, roll me back to my initial database. Simple. It says, we're going to drop price and delete the migration history table and leave everything else intact.
Perfect.
Really, really easy way to work with an existing database.
I like it.
Perfect.
All right. So what do you say we turn our attention to managing transactions? So now that we've sort of seen the database and worked with the data, I think it's time to turn our attention to transactions. So let's go ahead, take 10, and then we'll come on back.
Perfect. See you soon.
Chugga, chugga, chugga.